Arjo is a robotics software engineer at Open Robotics, you know, the organization behind ROS. And
yes, so he's going to be talking about how to simulate and test underwater robots by using Gazebo Sim. You know, Gazebo Sim is the latest version of, let's say, version of Gazebo, the simulator that ships with ROS. Mm-hmm. So, hello, Arjo, are you ready?
Yeah, fantastic.
So there it goes. Yeah, you can go. The audience is all yours. Arjo, sorry to interrupt you. There is a kind of error here that the audience cannot hear you. Just a second while we solve this problem. You know, those things happen, and but we are going to solve it very, very quickly.
No problem.
Can you tell us about where are you now located?
Okay. Is the audience able to hear me now?
Yes, exactly.
Okay.
Now
great.
you can go with your presentation.
All right. Okay. Sorry for the slight technical glitch. Welcome to today's session. Since we're on the theme of underwater robots, we'll be discussing simulation of underwater robots in Gazebo Sim. So, a little bit of background about Gazebo is you probably first heard of Gazebo Classic. Those of you who worked with ROS, it's a simulator that ships with ROS. So it was started 2002, and it's been now like about 20 years in. So around 2019, we decided to refactor Gazebo, and that became Ignition Gazebo. And recently, we've gone back, rebranded as Gazebo for other reasons. And so from now on, we'll be releasing it as Gazebo Garden in the next upcoming release. So let's talk a bit more about what we're going to do today. So today we're going to be testing an underwater robot. This is the robot we'll be testing. It is the Mobari LRAUV. It's the long-range autonomous underwater vehicle. And this tutorial is really geared towards people who really want to learn how to build a simulation from scratch. So we'll be going from scratch and building out the whole world and showing you how you can use the world and create unit tests around the world so that you can prove properties about the robot or things you want to do with the robot. And then we'll finally bridge this to ROS. So first of all, let's talk a bit about Gazebo. So if for those of you who don't know, this is how you install Gazebo here. It's already installed, should be installed on the ROS project if I'm not wrong. And to run it, you just run Ignition Gazebo. And you should, at the end of the day, get a blank window that looks something like this. So if you take a look, it'll look something like this. This is an empty window. That's how you bring up Gazebo. So with that aside, I'm going to now dive into our tutorial. The first thing we're going to do is if you check out, so let's go back to the tutorial. There is some code that is already, hang on, sorry, my bad, technical glitch. Back up. Okay, one moment. My bad for that. So there is some code that's already available. So if you go to this GitHub repository over here, this code will be there. It should be cloned into your repo, your ROS checked already, if I'm not wrong. So inside this is basically a sort of template of how you would set up a ROS, a Gazebo simulation. So there's two parts. The first thing we're going to talk about is this folder, Maritime Sim Tutorial. And inside here, you'll see something that's called a simple AUV. This folder has a folder with the model. And you will put the models will go inside here. There's the world folder. And there's a CMake file, which the job of the CMake file is to copy all of this and export the correct environment variables. The environment variables are set inside the hooks folder. So that when you run dot install setup.bash, this should load all the worlds inside here. First thing is currently our folder is very empty, right? And let's start by bringing in some code, right? So the first thing is, for this entire tutorial, the way I've set it up is you can use Git to check out individual steps. So for instance, now if I'm inside the folder, I can go here and say Git check out step 1. This will bring you up to step 1, okay? And in step 1, what's going on here is we have this new model. This is the model of the Tethys. So you can see that there's a SDF file here. So SDF is the way we define simulation constructs in Gazebo, right? SD format. So this is an example of an SD format. It's the model. I'm not going to go into details of this because it's very long. What is of interest, though, is our world. So in our world, we have this new world called Water World. Inside Water World, what we have is we say the world name, right? We include it, use the pose, and then we say that, okay, import the model Tethys. So the model Tethys is over here in the models folder. And it should import Tethys from here. And so what do we do now? We will build this folder. So let's build it. And I could kill Gazebo. Let's build it now. Wait for CodeCon to warm up. All right, it's taking some time to get started. Okay, there we go. All right. For a moment there, I was thinking, what happened? So we built the folder, right? And now this world is called Water World. So what we're going to do is we're just going to type IGN Gazebo Water World. I'm going to give the name of the world, waterworld.sdf. And wait, first you must source install. Sorry, my bad. So we installed setup. If you don't source it, it's not going to work. And you should wait for some time, and you will see this not very nice this vehicle here, right? Actually, I'm very curious why it's still like this. One moment. Get cool. Okay. I need to give me a moment. So if you get full, you'll get a nicer vehicle. Let's build that again. Because this is missing texture, so it doesn't look that nice. So I'll pull up a nice vehicle for you. Give it some time. Okay, we'll give it some time to load. There we go. Now you've got the full nice texture. This is the vehicle we'll be simulating. Right now, there's no physics attached to it. So if you just run, it's going to fall. Because by default, the world has a gravity, right? So Gazebo has gravity, so it's just going to keep falling if we run it. So the first thing is we're going to introduce some physics to simulate the thing, right? To make sure that it's an underwater vehicle, right? We don't want the underwater vehicle to keep falling. So we'll add buoyancy. So let's talk a bit about the forces we're talking about here. So these are the forces that we want to simulate: buoyancy, weight, thrust, and drag. By default, Gazebo already has the gravity set. You can disable this by going and setting it in the settings, but we're actually interested in setting the buoyancy now. So what we're going to do now is we're going to add buoyancy. And the way we do this is we go and run. We go and add this to the world. So what we're saying is we're telling the world that this world should have a uniform buoyancy of 1,000 kilograms per meter cube. For those of you who don't know, 1,000 kilograms per meter cube is the density of fresh water. Salt water is about 1,025 kilograms. So this, let's just add this now to our world file. So we'll be working in the world file mostly. So what you can do is you can paste it inside here, right? And right, we can add it in. Now, if I want to just run it as is, there's going to be a small problem. So if I run this as is, right, it's going to be a small problem because I can't build. And what we've done is we've added what's called a plugin. So if you go to Ignition Gazebo, you'll see a list of plugins in their repository. So this is one example plugin. This is the buoyancy plugin that'll simulate buoyancy. So if I run this, right, yeah, I should expect things to happen, but it does not happen. Just give it some time, and you'll see that you don't see a world here. So Gazebo is actually made of many, many small plugins, and once you load a plugin in, what happens is by default the world loads some basic plugins that allow the system to run. These plugins are missing now, so we need to reload them by hand. So let's go and load them in. Right, we're going to tell the system that we want physics to be running at this real system. We want to add the physics system, and these two systems are basically meant allow the user to interact with the world. Otherwise, this world is running headless in the background. That's why you can't see it. So let's add these in, and we should be able to see after we add these basic systems in. We'll be able to see. We should be able to see the world, right? And now let's go and kill our world. Let's build again. All right. So here is our world for Gazebo. And this is a simulator under the same vehicle underwater. And we're going to be running it on the spot, right? You see there's no sinking, right? So this is kind of what we want because now we have buoyancy, so that will counteract the force. So buoyancy will counteract the gravitational force. But we're still not done yet, okay? Because for submarines, we expect to have this thing called a restoring moment. And the idea of restoring moment is that if I rotate this, right, by a bit, so what I'm going to do is I'm going to copy this file and create a new world where I rotate the vehicle a bit. What I should expect to see, right, is something slightly different. So let's go and copy this file. And did it work? Okay. And rename this to restoring moments. So we're going to call this restoring moments. And what I'm going to do here, okay, there we go. And what I'm going to do here is we're going to rotate this, make it pitch a bit. So, so we're going to pitch it a bit. So over here, the pose, let's change the pose of the vehicle along the X, Y, this is the Y-axis, so we're going to rotate it a bit along the Y-axis. So we're going to make it tilt a bit, and we expect it to come back up, right? So let's go back and do that. There's a code editor. And we do it like this. Right, so we const build again. And we go restoring moments.sdf. We're going to call restoring. Right. Now, we should see the vehicle somewhat. So if you see the vehicle, right, if I look at it this way, it's kind of hard to see. Wait, hang on. It's hard to do this on like construct, but you should see it slightly tilted, right? right? You can see it's slightly pitched, right, along here. So it's not straight, it's tilted. And what we are going to see is it just stays tilted, right? So if you ever see an underwater vehicle, right, if you put it underwater and you push your water board, right, it normally will automatically push itself back up. That's the correct behavior, but here it's just tilted. So this is because the center of buoyancy and center of gravity are in the same spot. So for those of you who don't know, here there's two things in a submarine you watch out for: the center of gravity and the center of buoyancy. And by default, we want the center of gravity to be below the center of buoyancy, so that if the submarine gets tilted, the buoyancy will push it back to its correct location. So let's say it's tilted this way, the buoyancy will act on the force and straighten it out. So that's what we're going to be doing. So what we're going to do is really, really simple. We're going to go inside the model and we're going to tweak the collision mesh. The reason we're going to tweak the collision mesh is because the buoyancy plugin uses the collision mesh. So we're going to go here and go to the meshes. Let's say we go to the model meshes, and then we're actually going to go and tweak that a bit so that we can fix that. So let's see, line number around model, right? So the model, line number 16, we're going to add some. So line numbers, right? So around here, you can see here, the collision part, we're going to add this, right? So for those of you who are having trouble underscore the number, so we're on step 3 right now. If you run this, it should bring you up to speed straight away. So here we go. We're going to add this. And what this does is it moves the collision, which is what is used to compute the buoyancy, a bit down. And by moving the collision a bit down, what happens is the center of volume, well a bit up, sorry. 0.07 is up. Okay, I'm sorry. What happens is that the center of buoyancy goes from the center of gravity and it goes up a bit. So what you'll have is the center of buoyancy above the center of gravity. And once you do this, what we will see is, what we'll see after this is we're going to see this straighten out. We'll see it try to straighten out, and it should oscillate because we don't have any hydrodynamics to damp it. So we'll see this shake, right? So we'll be going to see it again, and we'll see it shake. So for those of you, we're going to build again, as usual. We're going to run the same world again. Give it some time. Okay, so this is the world. Remember, the robot is still tilted, right? So if I run it, I should see the robot shake. So you see the system is going up, and then it'll go up, and then it'll go back down, right? So you can see it's sort of like oscillating. This is the correct behavior, although it doesn't seem very realistic, because if you put it in the water, right, you expect the system to not oscillate. So what we're going to do is the next step, we're going to add something called hydrodynamics. Hydrodynamics is the system that's responsible for things like drag, added mass, and these behaviors are what sort of damp the make sure your robot gets slower in the water, right? So if you move, there's always a drag acting against you in water. And so we're going to add those systems later on. All right. So first we will do this. And so this is really going into the details of how. So what we're going to do now is we're going to talk about, before we go and do that, what we're going to do is do something called model composition. And what model composition allows you to do is that it actually allows you to take a model and then build a new model on top of it. So what we'll do for this is we'll create a Tethys equipped and Tethys. So we're going to create two files. First, we're going to create a new model called Tethys equip. So we'll go inside our code editor here, right? And here we'll create a new model. Okay. Create new folder. To create a new folder, we call it Tethys equip. Okay. Right. And Tethys equipped allows you to do some modifications. So what we're going to do here is we're going to add all of these files. So the first thing we'll do is we'll add a model.config. The model.config is basically just some metadata about what the model is. So we'll just add that. And the reason we're doing this will become clear in a moment's time. So we'll add a new file, call it model.config, right? And we add it. And now we're going to add another file here. So like here we have, if you can see, right, there's a model.config and the model.sdf. So the model.config just says this is the model's name is Tethys equipped. It has a model SDF, which we are going to create now. And you're going to put your name here. So, I'll put my name. And you will put yours and then your organization, and you give a description of the model. The other thing we're going to do is we're going to add the model SDF, right? Since we said we need a model SDF. And what we're going to do is model SDF. Nope. Let's create a new file. I'm going to call it model.sdf. Right? Give it some time. And we're going to add this. So what this SDF file does is it says include Tethys, which means I'm just copying the Tethys and including it here. And the reason we want to do this, right, is there are some things that we're going to add to this Tethys model, like the hydrodynamics, that are unique to the model. So the drag, for instance, of each vehicle is unique, which is why we want to add the drag plugins to this equipped model, right? So what we're going to do now is we're going to change our include that to use Tethys equip, right? And we're going to add that here in our folder. So remember our this thing, we're going to change this to Tethys equipped. And this should load, this will load the new model we created, okay? And just to test, we're going to check whether the system still works the same way, right? So both of them have, right? So whether the system still works the same way, let's go and test that. So back to our terminal, we will conn build. And we will test it. So it says cannot find, oh, I made a spelling mistake. Okay. So Tethys equip is spelled correctly there. Here I missed the I out. So let's add the I in. And let's add the, okay, let's go with that. I added the I in, right? Wait, sorry. Here. So I added the I in inside the world. So this is the restoring moments thing. We're going to build again. Right. So this is the vehicle, right? And then we're going to see the same behavior, right? The oscillation that we saw last time, right? You see it rock back and forth, right there. So it's going to keep rocking back and forth. So now we want to implement drag so that this gets drag and added mass so that this gets damped. So that's called hydrodynamics. What we have is now what is called a hydrostatically stable model. So it has the correct hydrostatics, which is the buoyancy and the weight. But now we're going to add drag, which is what makes the vehicle move slower in water. Okay. So we're going to kill it. Say goodbye to that window. And now, so what are we going to do? For the drag, what we're going to do is we're going to go to status equip, because drag is unique to each vehicle, as I mentioned, right? So if a vehicle doesn't look like if it's a ball, it has a certain drag. If it's a square, it'll have a different drag. If it's like a very thin profile vehicle like this torpedo, it's got a very low drag profile along the front axis. So we're going to add the hydrodynamic damping. And this part, you got to bear with me, because we're going to copy paste this chunk. These numbers, right? These are, oh, sorry, my bad. Forgot I can't double click on this without sadness happening. So these numbers over here that we have, these are pre-calculated from like the model, and they demonstrate the drag on the vehicle, right? So this is the drag, sort of drag coefficient. And the reason we have so many numbers here is to make sure that, you know, there's a drag in the X direction, there's a drag from the Y direction, to take into account the 3D. And there's also the added mass, which is sort of, when you have a vehicle in water, it'll displace some water. So when you move, you need to move that additional mass along with the vehicle itself. So those are the few things it simulates. If you're really interested, you can go and check out the hydrodynamics plugin on Gazebo Sim. As I said, there's many available plugins. If you click this link on your own down here, if I click here, I won't be able to open it in a new tab because I'm using the contract system, but you'll be able to see a list of available plugins out there. And this uses what is called Fosson's hydrodynamic equations, which I again have linked you to the book in which this is found. And so we're going to put this plugin in, and then we're going to see that the drag will stop the oscillations from happening, right? So we're going to add the drag. Okay, just slap it in here. Right. And we're done with drag. So we're going to just run this. We're going to build it again. And now when we run restoring moments, right, we should, let's wait for it to come up. All right, here we go. We should see that restoring moments will have, if you see the vehicle moves up, but it sort of stays flat. So what's happening now, it is moving up and down a bit, but it's much slower, right? What happens now is that because we've added the water drag, the vehicle doesn't sort of, you know, go crazy and oscillate, right? So it stabilizes. This is the behavior expected in water, right? You put a water board in water, it'll go up and then oscillate a bit and then it'll flatten out, right? So if you've ever gone swimming and you put like your, you know, the float or a surfboard underwater, you push it down, it's going to come back up straight and then stay flat. That's the behavior we've simulated. The final step we're going to add is, of course, this needs to move, right? And in the interest of time, I'm probably going to skip the testing section. So we're just going to get this to move and then hook it to ROS. Okay, that should complete our 40-minute presentation because we are running out of time. So we're going to add thrusters. And thrusters allow you to, well, move the boat, right? So there's a thruster plugin. The documentation is here. You can click on this link. It'll open the documentation and explain to you what each of this is. But basically here we say we're, my bad. We're going to go back up here, right? We're going to have a thruster. The namespace, we're calling it TEFIS. This we'll talk about in a moment's time. The joint we're interested in changing is propeller joint. And the reason you got that is actually you can go and check out in your code base the propeller joint. So Tethys, go to Tethys, and go to, if you go to the model.sdf, you can just Control F and find the, right? That's a propeller. We're looking for the joint. So we just look for the joint. So there's a joint called propeller joint. So this is the joint we want to spin around. And the thrust coefficient is a random number. It's not a random number, but it's a number made by engineering. There's an equation for this. Again, click on the thruster plugin, you'll find the equation. And this basically tells you how the number of RPM relates to the force applied on the system, the fluid density, which is that of water, and the propeller diameter is how big the propeller is, right? So these can be tuned. For water, 1000 is pretty good. Is normally the standard 1000 kg per meter cube. So we're just gonna go and throw this in and hope for the best as usual. So we're gonna go thrust and go to our model equipped, right? We're gonna add this to our model equipped, right? So we're gonna add it as another plugin inside the model, right? And we're going to, what we're gonna do is we're gonna run the simulation again, right? And see that, and then we're gonna try to control it. Let's go. And we're gonna call con build. Again, we're building the thing to copy over the files. And then we're gonna ignition Gazebo, you know, check out our latest version. Okay, ignition Gazebo. And model we're gonna do. Oh, wait, sorry, you could just have use the same. No, we're gonna do water world. Stop. This one you need. We're gonna use water world because we want it flat, remember? So restoring moments at the vehicle started out at a slope. We want it flat, so we're gonna do water world. All right, we're gonna do water world. And so you should see the vehicle. Again, nothing very interesting right now. If we run it, it's going to be stationary because nothing is running, right? So there's nothing running. This world is the vehicle starts out flat, so there's no restoring moment needed. What we want to see is this vehicle move. And so to do that, we're going to go and in another tab, we're going to open a new tab. And so ignition, so Gazebo internally has its own topics. These are different from ROS topics, and they have to be bridged. So you can see the list of topics here, right? And so they have to be bridged. These topics normally we bridge to ROS and we control using ROS. But first, we're going to try controlling using ignition. Okay. So what we're going to do is we're going to copy paste this chunk. What it does is it takes the it says publish to this topic, which is model. The namespace is where you describe the Tethys, and then we say the joint, the propeller joint, right? And we say the command position. We're going to give it a spin of -31. The reason -31 is because this propeller is spinning in the opposite direction. So a negative number will make it spin in the correct in the correct direction, but push it forward, right? So we're going to see that. And
5 minutes, Arjo.
Up our system. We're going to paste it here. And we're going to say run. And what happened? And it didn't work. Only argument was expected -31. Give me a moment. This is bad, but I think there's something wrong with the parsing here because this definitely works on a normal terminal. So it's not working here, but what we'll do is we'll bridge into ROS and then do it from ROS, okay? So I'm going to skip over the unit testing part because we don't have time in the interest of time. What we're going to do is we're going to build ROS, right? We're going to build so to bridge this to ROS, there's a ROS bridge, right? And I think, let me see. I think, so there's a ROS bridge. So if you click on build, right, you'll see that there's a ROS bridge I've checked out for you. This this ROS bridge bridges things, and it bridges the ignition topic to the ROS topic. So let's do that. What we're gonna do is we're gonna build this. We have to tell the system that we're using Fortress, which is the version of Gazebo we're using, right? And then we're gonna build it. And then we're gonna run the parameter. What we're gonna do is we're gonna run the parameter bridge. So what we're doing in the parameter bridge is we're saying that this is the ignition topic we want to publish to. This is the float message we want, and and we say that this is the topic that we are interested in, and this is the double. So we say ROS2 run IGN bridge. So we're gonna run this in a separate tab. All right, click on build. We're gonna run ignition water world again. And then here in this one, we're gonna cd the maritime ROS, right? And then we're gonna install again source this. We're gonna run this, okay? And I think if you run ROS2 topic -L, oh sorry, not that -L, sorry, topic list. It's taking its sweet time. I don't know why, but you should see this topic appear on ROS, right? So we're gonna run the simulation, press play, and now we're gonna tell it that let's move. Okay, let's move. So we're gonna get this to move. And we need Gazebo, and let's go. And nothing happens. So something was wrong. I wonder what it is. Give me a moment. Okay. So one of the good things about this whole system is I've set it up so you can just check out. So git stash our changes and git check out the last good version. So we're gonna check out step 8. Let's go back to it. Step _8. So let's just okay, we're gonna go to step 8 and we're gonna try that again. Hopefully it'll work this time. Demo always goes wrong. It's the demo bug as usual. Are we done building? So there's more about unit testing and stuff, and you can go through this on your own later on. There is a link. Again, the ROS check has a link to the original system. I'm running a bit over time. I'll be done very soon. So let's try again. And hopefully this time it works. All right. Let's see what went wrong. And And it's still not working. Okay. Well, I'm gonna have to call it in. We're out of time, but it should move forward. I am very curious why it is not moving forward. Okay. Yeah. Okay, so I'm gonna leave it at that for now because we're out of time. Um, yeah, I think. Uh,
Okay, thank you, Arjo. The presentation, fantastic presentation. I really love the. I've been working also for Robotics for this, and it's really complex. So very well done. Thanks a lot. So please post your questions for Arjo in the chat, and vote for the questions that you find more interesting.
In the meantime, Arjo, can you be on your screen? I can see you now. Okay. So yes, so remember that there is a tab where you can put the questions and you can vote for them. So in the meantime that the people is putting the questions for you, Arjo, I'm going to ask you one question of myself. Then my question is, can you tell us about any real robots project that is using those Gazebo simulations for their real underwater robot projects?
so I think there are quite a few. I think this is this robot I just showed you is from a real robot. So we do have this working on a real robot, which is kind of why I'm like, why is it not working now?
Oh.
It's it's the Mabari Somaturi Bay Aquarium Research Institute Long Range Autonomous Underwater Vehicle. I know of at least a few other groups that are working on maritime vehicle stuff. And yeah, so the maritime vehicle domain is, and it's growing right now. So there's now a new ROS working group that is just working on maritime stuff. Again, shameless plug, but if you're interested, you can join it. The information's on discourse. But yeah, there are quite a few vehicles now out there, and this LRUV is one of many.
Of them, okay. And then how is the procedure in order to develop for those robots? So do you work mainly in the simulation and then at some day, I don't know, some day in the month, so you go and put it on the water? So how is that procedure?
So the idea is to go and start work on simulation and then test your work underwater, right? Because with underwater robotics, there's always you don't get too many tries. You go wrong, then you lose your robot. So the idea is you test it in simulation, and so yes, Gazebo is used to run the simulation beforehand and then deploy. Of course, what you're seeing here, this robot was developed way before Gazebo could do maritime simulations at all. The one that I'm demoing here. So they had their own simulator, but they have recently switched over to using Gazebo, and yeah, and we're sort of, there are other groups around the world that are doing this. Again, I'm not the only one. I think this guy called Clyde McQueen has done a simulation of the Blue ROV, which is a very low cost $4,000. Well, low cost as far as maritime systems go, $4,000 vehicle.
Okay. Okay. Okay, let me ask you one question from Roberto Segers that says, how to command the simulated submarine to go up and down in the water? It is also by publishing a Float 64 message, for example, on a topic.
So you would add plugins, right? And so I've only added a plugin that makes it go forward now, but there is something called a buoyancy system plugin. Can I just maybe link this to people? So there is a tutorial that this is based on for people who are interested. They can go and take a look at the following tutorial. Let me just give you one moment.
Yes. So we are going to put it on the chat here.
Yeah, you guys can put it on the chat so they can take a look. You guys can take a look at it. Documentation. Okay. Okay, wait, hang on. API and tutorials. Give me a moment. This is just.
Yes.
Just give me one more.
So our colleague Marco is going to get those links from you. And and we'll put it on the chat.
Yeah, I'll just send it in in one moment. So you can't do up and down control using the buoyancy engine, which is a system that basically fills the bladder with water and then releases it. Again, we didn't have time to go through everything because I started from bare bones, and it does take time to walk through everything. So I'm just going to put this here and let others take a look.
Okay, and but then if I have understood correctly, then by using those plugins, so for example, we could even do a keyboard teleop that pushes.
That is correct. That is correct. So I have not included a keyboard teleop again. As I said, we started from scratch, so we really had to go through every step, which is why it's not in there. Definitely, you can use plugins to do keyboard teleop. There are plugins available. The whole list of plugins actually is, if you go to that link, I think the documentation will have the plugin list.
Okay. Then here you can see the link that has been sent on by Arjo. It's been put by Marco for everyone, so you can check.
Then we have a question from Samuel Prieto, which says, what are some of the most difficult challenges while working with underwater robots compared to ground robots? I mean,
so okay, there's the real world, right? So with real world, so unlike real robots where you can connect to Wi-Fi and debug your robot, so underwater there's no Wi-Fi. Your best bet is either using a wire, or there are very low acoustic modems, and we do have Gazebo simulations for that also, but very, very low bit rate modems that run at like bits per second, like 1,000 bits per second at most, and they have like very high latency that use acoustics.
wow.
So sound, like I'm talking,
So communications go through sound, basically.
Either you use sound or you use a wire right now. So you don't really have too many options with communications. The other big challenge I would say is, it's just, if you're doing hardware, then if you're just like coming up, I mean, I've done some robots myself. I mean, mechanically it's hard to deal with. It's a lot of leaks and stuff. Sensor suites are also very different. So you have poor perception. You would be using like sonars, DVLs. These are like different sensors that we use. It's a very different set of sensors that we actually use underwater.
And also, you are mixing
in simulation. I think the hardest part is the part which I showed you, which is getting the hydrostatics and hydrodynamics right. Sure. Those two are really, really critical to getting it right. And it, yeah.
Do you have time for
for another question. The last one from Maladi Nagasubhash. He says, are there in open source robots like this where the ROS developers can contribute to? So
open source underwater robot, I think there might be some open source underwater robots. I know there's one from Ardu pilot group, but for ROS developers, I would say that we don't yet have a platform which we can say is an open source platform. But as I said, there is a maritime working group, and if you go to the ROS discourse, so discourse.ros.org, we do meet every Tuesday of the first Tuesday of every month, and we try to sort of push the state of underwater vehicles in ROS and Gazebo. You could, depending on what you want to work on, you're welcome to actually do that, or you can just send me an email if you're actually interested in working on this stuff.
Okay. The contact details to contact you are on the notebook, right?
I think so. I'll just put my email here if anyone's interested.
Okay.
Fantastic. Then you have the email there in the chat. You guys.
I'll just put it in the Meet chat that I'm on.
Okay. Yes. So yeah, I can see one question. There are more questions, but we are running out of time.
I'll drop into the chat and see and answer as I go along.
Yes.
All right.
There it goes.
There you go. Fantastic.
Fantastic. Thank you very much, Arjo.
All right. Thank you.
Thank you, Arjo. Great first speech, right?
Yes.
Very complex.
Yes, I think that we had some panic moments of the audience, because I'm sorry that if you felt overwhelmed, because the talk of Arjo was a little bit, so it requires to move a little bit fast.
Yeah, and it's a
Hey,
very
Steven,
deep
you hear me?
topic also.
Yes.
It's a very deep topic because actually I was working on a project for that, and
Hello,
it's a lot of
Steven?
work.
You hear me?
So doing that in what, 20 minutes or so?
40.
40 minutes.
I don't hear you.
It's really tough
It's a lot,
to explain
yeah,
that.
yeah.
So sorry about that, guys.
Yeah, but don't worry, because now you can go with a notebook at any point in time. And it's also, if you go to the notebook, through the notebook, you will see that how well structured it is and how the answers to the different parts are being set. So you need to go step by step, and then you will get all the most of this conference, of this speech.
Okay, so
What is next?
well, now it should appear a tiny box somewhere where you can rate the speaker.
Yes.
And at the end of the conference, we will tell who has been the best speaker. So please rate that.
Yes. So, and now, so we need to go to the, let me see.
The docs, right? Also remind you that to open the second project, you have to go to the docs tab, and there you can find the project that you have to start opening for the next speaker.
Exactly. The link is now in the docs tab. Okay? So if you have rated the speaker, you need to change to the docs tab in order to see the project. So start doing now, because it takes some time. Then in the meantime that the project opens and we change to the next speaker, what do we have?
Yeah, so now we have a prize quiz.
Okay.
So
great.
it's a video that you'll have. It's a video about
Hey,
our
Steven,
sponsor
do you hear me?
we'll talk about it. But basically, the person that answers the question faster will get a T-shirt like this one and a mug like this one.
Yes, and the first video that we are going to do is a video about our sponsor, Proxima. So what you have to do is to watch this video. Within the video, you will see several information pieces, and then at the end of the video, there is this question that Miguel has mentioned. Then you have to answer as fast as possible, okay? So we are going to play this video, and after the video, before we get the next speaker, we'll announce the winner.
Yeah. So let's see you in 5 minutes then.
Yes. welcome back. So, very good. About the question from the video, is the correct answer is the core. So you can find the ROS Discovery Server at the core of Vulcanexus. And then the winner is...
Roman Baur, right?
Exactly. Congratulations, Roman Baur.
Yeah.
So our team will contact you after the conference in order to send you the t-shirt and the mug.
Whoa.
Congratulations.
For loads of coffee for us.
Yeah, exactly. But for him.